In the last slide, we were introduced with the Euler's form of representing a phasor in a complex plane. This figure helps us visualize how a complex phasor e raised to j theta looks in a 3D space with the x-axis as the real axis, the z-axis as the imaginary axis as plotted against time on the y-axis. The projection of this phasor e raised to j theta onto the xz complex plane can thus be seen as a circle. The projection of the exponent e raised to j theta on the real axis time plane can be visualized as shown in the red diagram. The real component of e raised to j theta or the real component of cos theta plus j sin theta can thus be clearly seen as cosine of theta in the figure. Similarly, the projection of exponent e raised to j theta on the imaginary axis time plane can be visualized by the blue diagram, and the real component of cos theta plus j sin theta can thus be clearly seen as sine of theta. In the last slide, we were introduced to the term of angular frequency and its projection on the real and imaginary axis using a rotating phasor z of t on the complex plane. We now proceed to understand how this phasor can be decomposed into sine and cosine waves. Let us assume that at t equals to 0, our phasor with modulus r is positioned at the real axis. It has some constant angular frequency, that is plus pi radians per second, which also means it completes 0.5 cycles every second. We now draw these two accompanying figures to understand the trajectory of the phasor z along the real and the imaginary axis. Specifically, this figure below shows the projection of z onto the real axis, while the figure on the right shows the projection of z onto the imaginary axis. As the phasor rotates counterclockwise with omega equals to pi radians per second, we see that after 2 seconds the phasor completes 1 revolution. We can also see that the real axis projection completes 1 cosine cycle after every 2 seconds, and similarly the imaginary axis projection completes 1 sine cycle after every 2 seconds. Hence now we have a pictorial representation of e raised to j omega t is cos of omega t plus j sine of omega t.